Hey everybody, so today I'm going to talk about the prefix problem and well, this is a technique, so I'm going to talk about that and perhaps I could explain that with the well, I was just thinking perhaps I could explain this with an example, but perhaps verbally is the best way to go. So the prefix sum, let's start with the definition of that one. So the prefix sum of an index I is sum of all the numbers that are present in an index 0 to I, and it includes I as well. So basically it's the cumulative sum. So that's what you need to remember. Now there are a couple of benefits of this thing, because if we have the prefix sum, then we can do other things, and we can find the sum of the subarray. That's one thing. So there are like few things that we can do, right? So let me draw some diagrams and explain what I'm talking about. So we have this is an example array that we have. Now prefix sum array, let's see what would that look like. So the idea with these sessions is that instead of like procrastinating, I should be explaining stuff no matter the quality, and because of the repetition the quality would improve. So I would not be caught in this perfection loop, right? So that is the idea. So here, this is the zero index, and in the corresponding index of prefix summary, we'll have the sum of all the number up to this point. And since there are nothing towards the left side of this one, so currently the sum would be 1. Now when we want to find the sum of another or the next one, right, that would be 2 plus the previous sum, so 3, and then we have 3, so 3 plus 3, that will be 6. So again the previous sum, 6 plus 4, we get 10, and then 10 plus 5, we get 15. So there is that. This is how we get the prefix sum. Now let's look into the code for this one. So we would loop over the original array and they calculate the prefix sum. Right, so let's iterate over the original one, and then we have the cumulative sum in this variable. As we go along, we're going to increment it, or rather add to it. So we are picking array I, add I, and then we're saving that or adding it to the sum. Now we need to store this somewhere, right? Because there are like bunch of different cumulative sums, right? So we need to store. Where do we need to store? Let's create the array, and the size of the array would be equal to the size of original array. Why? Because if you look into the diagram, the size of this one, prefix sum array, should match with this array size. So we have that, and in the corresponding index we are going to store the cumulative, and in that, and of course you can return the cumulative sum array. So that is one thing. So far what you have seen is how to generate the prefix sum array using a variable which we use to keep track of the cumulative sum at that point. Now moving on, mm, let's pick off, well, there's a problem that we must do, and this is the one. Given an array of integers and integer target, so we'll be given an array and a target, find a subarray that sums to target. Let's write that example here and then we can talk about it. Okay, well, why won't you this right? Okay, so sometimes it does do that. So we have this is the array, and then we have target. Okay, so these are two things. We are given an array and a target. Now we need to find a subarray that sums to target. So it has to sum up to that point exactly. Return the start and the end indices. Right. So it's a subarray, so it can start anywhere, can end anywhere after this point, right? So like it could be here as well, could be here as well. Now, if it is in the beginning, then we just need to, if let's say this is the subarray, right? If it is starting with 0 index, then we have the cumulative sum of this thing, right? Let's say we have that, then we can simply compare if the target is equal to the cumulative sum at this point, then we would know, okay, all of this is the subarray and we can return these indexes. But then there is an edge case and we must talk about it. Let me just get rid of this and this. So what happens if the array that we are looking for is here somewhere? How can we get the sum of this subarray using the new technique that we learned about, which is prefix sum array, right? So what we must do is that we need to subtract the prefix sum of all the elements that are before the start of this one and all the, and we need to subtract that out of this thing. So let me just explain that with a diagram. So let's call this I and J, right? Now this is J. Now this is 0 to J and this is 0 to I. Now in order to get this, if we have this and this, we can subtract 0 I from ij, right? And that would give us some, that would give us I and j. So how can we put it in the words? Perhaps we could say, okay, if in order to find the subarray sum using the prefix sum technique, what you need to do is you need to take the subarray sum, or the prefix sum. Now I think this is the kind of thing that is hard to put into the word, so I'm not gonna go as far as to do that, but we have the formula here, right? So although this is not stated here, but this is like the prefix sums, right? So this is a prefix sum from 0 to j, from 0 to I. If you want to get ij, then you have to minus that. Now here is a mistake. This one should be I, because why? Because we don't want to subtract I, because if you look at this, if we subtract I from this, then it's not going to be I to j. So we want to make sure we subtract everything before I. So that's why this should be I minus 1. Okay, so now you have that. Now this is the formula. And now how can we make use of it or implement it? Let's think about that. So what does this equation tell you? Well, this tells you that I minus 1 would be less than equal to j. So it can't be equal actually. It just I minus 1. Where would I minus be? I minus 1 will always be less than j. That means by the time we get to j, if we are scanning through the data structure, by the time we get to j, we would have seen I minus 1, right? Because I minus 1 would be somewhere here, and when we get to j, at that time we must have seen it. Now when I say seen it, is there, so that tells us that I minus 1 will come before j, and this is the equation, right? So if we have these two, then we can get this, right? So now perhaps we can override this by bringing this one over here, because as we have said, this is something that would appear first, and we can use that to our advantage. How? Let me explain. So the point is, where do we get this? What is this? This is the target. So we can substitute this thing because it's a given, right? So we have this and then we have this, because as we are going through the array, we'll have a pre-calculated prefix sum, right? Now we will feed that value into the equation, right? So as we're going through the array, I would feed the current prefix sum to this, and then I'll subtract the target. Now by the time, now in order for this arrangement to be true, let's say the target is 7. So no, let's not go there. Let me think of a better example. Okay, in our, let's say this is equal to target, right? The combination, this pair is what amounts to target, right? So instead of, I wonder what can I do about it. Like, I'm just trying to understand how to argue this one. As I'm going through the array, at that point I would have seen I minus 1. I would see that first, right? So that means if I'm going through the array and I'm keeping track of all the values that I have seen, where do I would keep track of that? Well, I can keep track of that in a map. Okay, so if I am keeping track of that thing in the map, so these will be all the cumulative sum, right, that I will have keep track of. And once I get to this equation, now I try to get the current cumulative sum and subtract the target. That tells me that I need this value. So we can write it as this. We have x, we have target, and we have y. So this tells me if I subtract x minus t and get y, if I have seen y, which is a cumulative sum, then that means I have found the pair. What kind of pair? I found the pair. I think we better explain is this with this. I could say this is x, this is target, this is y. So I'm saying that if I subtract this from this, so saying this is target, this is x. Problem is I'm having hard time arguing that. Why is that? Maybe the idea is that you need to be able to talk about it, verbally. But how would one do that? Well, in order to find I think I'm going all over the place and I'm not really, or maybe I'm going too much in details and that's why it's just hard to explain. Let's try to explain this on the paper first and like on the whiteboard. Then perhaps it would make more sense to try to explain this verbally. So what does this equation tell us? If you are able to find y such that if you subtract x minus t, that leads to you to the value y, and that value is indeed something you have already seen, then that means we have found a combination, okay, of numbers for which this equation is true, but this is too mathematical. How do I express it as like intuitive? How do I do that? We better have a look at the. I think issues with the vocabulary. Perhaps I don't really have phrases, or not really vocabulary, rather phrases that would be suitable to express this, and I haven't like practiced this, and that's why. Anyways, I think this is a good way of thinking about it. So yeah, let's keep doing it. Okay, so how would one explain this? I could say I have found a number y such that when that is subtracted from x, it gets us the target. Mm, so let's put it in word. We have found a number y such that when subtracted from x leads us to target. Or even better way would be that y is the cumulative sum of the prefix array that occurs before our subarray. Now perhaps it's not good to explain in terms of that, and I noticed that the Algo Master was not also able to explain this. They kind of glossed over it. So this is perhaps they just alluded to some approach, and they were like, okay, this is a two sum problem, but this is not really, I mean, it's a similar problem, but there is no sum, right? So I feel it is not good to invoke that, and the only reason that people try to do that is because they don't really wanna solve the problem or explain the problem. They don't wanna perhaps go too much into the depth. So that could be a reason, but yeah. Now, how do we talk about the implementation, right? How do we get into the implementation? Because I want to be too practical about it. So, first thing first, we're gonna have to iterate here, and then we'll have store the cumulative sum. And when we have the cumulative sum, we also want to store the index. This sum is 4, right? I remember in a tutorial I saw that when they were storing the index, they were decrementing it by 1. What could be the reason for that? And that is also one thing they did not explain implicitly. So, since we need the cumulative sum, so we can start with this. Can say, okay, do we need an array, or can we just get by with a number and less than? Okay, and then we have the cumulative sum in here, right? So let's keep track of that. And what are we going to do now? So there's the first scenario. After our target could be equal to, so the first scenario is that the subarray that we're looking for is at the beginning, right? Like this, it could be like this as well, there are a number of places, so it could be like this. So at this point we need to check if the target sum is equal to target, then we return what? We return 0 because it starts from 0, and I, since in the problem was mentioned that the last index is excluded, so that's why I do the +1 to make sure this is excluded. The other scenario is, so in each iteration we will be checking whether this is the index, the potential index, and also when we're considering the scenario, the starting is always 0. But let's say this one is not true, right? But we have to check it for each index, right? So here, what do we need to do? We need to check the difference, right? That formula that we have, right? We need to subtract x minus target, right? But then what is the x? X is the sum, right? And then we get the y. And now we're gonna say, okay, does this map dot get Do we have it somewhere? Instead of searching here, perhaps I could do something like this: map.get y. I mean, get won't do it. We just need to check whether the number that we came up with, is this really there, right? So we need to say, is this really there? Has. Maybe number would have been fine. Map get y. Okay, so that's the number that we're looking for, and we're saying, well, let's call it val. I don't can think of a better name at the moment. So saying if the value is present, is not null, that means we found something. Or perhaps we could say if it is greater than 0, then we return well, and then we of course return the ending, and just to exclude, because in the question it was mentioned, when we have arrays like this is I, this is J, so we wanna, J represents the ending, and we wanna exclude the right index, so that's why we add one. But I was just wondering, why do we have so if both of these conditions are not true, then that means we need to store the current cumulative sum. Well, put, add, whatever. Oh, I think you have set method. So gonna put it over there, and then you wanna put it as I minus 1. Why do we put it as I minus 1? Because in the next iteration, when, so let's say this is the current iteration. In the next iteration, the I would be some value, let's say 3. Now this is I is equal to 2. Now this time we are saving this value. But why are we subtracting minus 1? Because when we will be at this index, and potentially we come up with cumulative sum that is needed is this one, then we look up for this one. At that point we wanna make sure I does not include this value. But why? should that not include this value? How do I like reference that, explain that? Yeah, I think this is a tricky point. The solution, they also don't really mention. No, instead of subtracting, it's like I tried to recall that and I couldn't, and I'm just you know. Oh, I think the idea is that currently we are at the index I, and in the next iteration, okay, basically we get the index for the cumulative sum, which when subtracted from x, right? But you do realize that in this scenario, let's say this is your target, this is your x, this is your y. The y would point to an index right before the beginning of t. So that's why when we are returning, we need to do plus 1. But this plus 1 and this plus 1, these both are for a different reason. This is to make it right exclusive, and this is to make sure that even though the index that we stored was for the current cumulatives, the index that we stored was it was for the index this cumulative sum was for, but the subarray that we're looking for would start right after that, right? So perhaps that's why we need to, do that. But yeah, this is what our solution would look like. I think for the first time this is pretty good explanation, and I think if I do it again and again it's gonna get better.